Hi, good morning. We want to talk about Cloud Foundry at SAP scale, specifically from the point of view of the routing team and the runtime team. Two very scalable components, but still we have some issues occasionally. A quick word about myself and Vladimir. I'm working in the routing team, routing and networking, so responsible for all of the ingress. And Vladimir is in the runtime team, responsible for actually keeping the apps running, Diego, and so on. So the biggest challenge is how we use Cloud Foundry. We're operating a pretty large-scale platform as a service for our customers, for our internal stakeholders, with a huge variety of workloads, huge variety of legacy and super modern components. And we need to support all of those, right? And on top of that, there's also just a lot of apps that are running on each of those landscapes. So we're stretching the term cloud scale every day. There is some design limitations in CF and some in SAP setup that we're working on. So this is our daily work, and it's very interesting. A few numbers. We have 30 production landscapes. Over there you see the numbers for the biggest. It's pretty big. 120K app instances in one landscape. You can imagine what the cloud controller, Diego, and so on have to do with that. We're running on the 4 major hyperscalers, including AliCloud. Each of those landscapes runs in 3 availability zones, and we have wildly different workloads. As I said before, we have microservices that are really keen on pushing the last bit of latency out, and we have people that have OLTP processing that are totally okay with running a request for an hour. And then there's HTTP 0.9. Yes, we've seen that. And the latest bleeding edge, HTTP 2, WebSockets, whatever have you. And people are really pulling from both directions. Some want to support even older things. Some want the newest HTTP 3 soon, I hope. Again, it keeps it interesting. All right, this talk is mostly about some of the stories and some of the things that we've experienced in our teams, some of the challenges that we've overcome, and the contributions to the community that arose from that. Also gives you some context when you see all of those weird PRs from us guys, why we're actually doing that. The first one is about GoRouter and root service hairpinning. It's a feature that is built into GoRouter for a long, long time, but eventually has been disabled by default because of a CVE. We're getting to that in a bit. Very quick recap of what a route service is. A route service is an interceptor for when you call an app. The route service comes in between, can do something with the request. For example, it can proxy it and actually call your app. It can also say, oh, rate limit is full. This is also how we use some of those things at SAP. One of the most used route services is actually a rate limiting route service. There's some authentication things and so on. But basically, imagine it as a gatekeeper that can do then something with the request. And hairpinning, in this case, it's an internal resolution of the request, is really useful if the root service is an app in the same environment. Because then GoRouter can save itself the whole round trip of going through the load balancer and maybe even NAT Gateways and so on, and just look up, hey, I know this app, I'll just forward it. Great. That's a problem, though, if you have external route services. And then there was a CVE. I'm going to get into that in a bit. So, regular route service request with hairpinning looks something like this. GoRouter has its route registry, so it knows about the app and its URL. It knows about the root service URL that is called instead. And we have the root service that is registered as a separate app. So when GoRouter gets a request to the app, it sees, oh, there's a root service, and will just redirect the request to the root service app. And from here, the whole shebang goes on. The route service app calls through and so on and so on. But this is the hop that we're saving. We don't need to go outside through to the route service app. We can go directly. For an external root service, because we don't have anything in the CF landscape on the Diego cells, it just goes directly, resolves the URL via DNS. Fantastic. Root service does its job, calls the app. Now the problem with the CVE. If you create a private domain, we put it in the evil org, that wants to steal all of your data, you can actually reserve the URL that would be used for the external root service into an app that is deployed on the Diego cell. And because GoRouter doesn't really check via DNS and doesn't do any resolution. It will go directly, hairpinned, to the root service app in Diego that can do whatever it wants. If it's clever, it can also forward to the actual root service, but in between you have a man-in-the-middle attack. So what did we do with that? We've basically added an allow list where you can define DNS wildcard lists of domains that are allowed. With that, we've allowed all of the internal domains where we know that if you resolve them internally, it's fine. And with that, we exclude the external ones, so we avoid the CVE scenario. This is the PR for that, if you have any interest. Cool thing is, this covers most of the root service requests that we have, because we have very, very few root service requests externally. But still, we have the risk, so we couldn't just allow it wholesale, right? The next bit that I want to talk about is improving the interaction between GoRouter, Envoy in this case with route integrity towards the apps, and Diego, for example, when Diego is crashing, or other things, where we might have misinformation about the root states that GoRouter knows and the ones that are actually live. So route integrity looks something like this, where you have GoRouter that communicates via MTLS with an Envoy that is part of the app container. MTLS ensures with its certificate that you're talking to the exact app instance that you're supposed to talk to. This is really important on a shared platform as a service. You don't want company A to call company B accidentally. So this has to be on. But the communication between Envoy and GoRouter is not always the most clear, because Envoy is basically just a pipe that sends requests through. Problem is also that Envoy, how it is used at the moment, will terminate the TLS connection. So it will establish the TLS connection before it checks if the app is actually there. So if the app is not there, it will just tell you, oh, gateway error, go away. But GoRouter doesn't know if the request went through or not. So it can't retry on the next instance. The customer gets the problem. And this is what we actually want to avoid. We want to use GoRouter's capability of retrying transparently so that you don't see if one of the instances of the many high availability instances went down. Another thing is that health checks, even when they're configured correctly, which is also half a miracle already, are not infallible. And this is actually where it ties in nicely, actually on this next slide, with the current talks about the readiness probes, I think. And then we had cases where the Diego cells crash, and those led to stale root information. We have tens of thousands of root endpoints that suddenly are on another port. And if then, with the root integrity, it tries to communicate, it sees a different ID and needs to retry a lot of times. So, which is why we've implemented improved retry management at some point. Basically, we made it configurable. Instead of the 3 hard-coded retries, we've added n, however many you want. We've improved some of the error propagation with the main goal to make sure that GoRouter understands that the request didn't actually ever go through to the app. Then you can safely try on the next instance. This is really the whole topic of this part, is making sure that GoRouter understands that it can safely retry on another instance. And one of the things we're working on right now is to also trace the request state. So whether it managed to do a TLS connection, whether it actually managed to send data and so on via this HTTP trace information, and provide that as part of the error handling in GoRouter. And then our next big task, where we also would welcome community participation, and we will participate, or we are participating in the community, is about the other side. So where Envoy is right now, what can we do there to make the communication clearer, that it actually could retry on another instance somewhere. We're exploring static and dynamic reconfiguration of Envoy, which right now is just not used, but it would be possible. We have the readiness probe, of which you will hear more today, I think, also from Amelia. And we're evaluating alternatives to Envoy. And this is maybe the big new thing. This will probably be an RFC eventually as well, to see if we can make something tailor-made for this specific thing that can also help us with expressing this information, whether you can retry safely. That's it from me. Over to Vladimir, who's going to tell you from the root service, from the Yeah.
I'm going to tell you about the problems we face with NAT gateways and dynamic ASGs. Starting with NAT gateways, I would like first to introduce what is the idea and when does this come into play. The NAT gateway, so this is a typical flow where we have the Diego cells. They want to contact something outside of Cloud Foundry. For example, this is the on-premise backend of some customer. Where comes the NAT gateway in play is that in actually to go outside of the hyperscaler, the Diego cells are placed in one subnet. The NAT gateway is configured as a gateway to this subnet. And then what the customer has to do is that they have to allow list the IP of this, so in their firewall, to whitelist this IP so that the NAT gateway can contact the on-premise system. But what happens on some of our landscapes is that we get connection limits on the AWS NAT gateways. For example, they have some limits of something like 55,000 open connections or up to 900 new connections per second. When this happens, the NAT gateway starts to drop packets, and when it drops packets on customer side, what they face is connection timeouts, connection resets, and they start to complain and get this infamous noisy neighbor issue, which we try to avoid. In production, this looks a bit different. So we have three availability zones with 3 NAT gateways. But even in this setup, we sometimes reach this limit on our busier landscapes. So what we did is that we created multiple NAT gateways for each availability zone. So this means multiple subnets like this. We have many subnets. And then the question was how to put the Diego cells into the different subnets. If we just deploy them, what Bosch does is that it first uses the first subnet, then the second subnet, so it's not working very well. So we had to switch to static IP distribution, and the most interesting part was that for each Diego deployment, we had to list the IPs in the order in which the Diego cells need to be distributed among the subnets. And this is how we achieve that each Diego cell lands in a different subnet so that they're equally distributed. This way, we had an equal load amongst all, and it's working fine. What the customers face, though, is that they have to allow list all the new IPs, which for some landscapes is fine, like we have just a couple of IPs, for some a bit more. But for some, they're quite a lot. So each time we introduce it, this is Patrick's teams, they also face it, so we get some tickets and customers think, oh, it's not working, why it's not working? And for example, they forgot the 17th IP. But this takes about a month and then it settles, so it's fine. The other interesting problem that we have, and actually this is a gold mine for problems, this is the dynamic ASGs, because on one side we need it. This is from compliance perspective, this is a must. But each time we try to introduce it, then something happens. And I have collected a couple of issues. So the most important problem that we have is that we partially abuse Cloud Foundry. We have some stakeholders that put all their applications, like thousands of applications, in the same space. Cloud controller is not working fine, but they have some workarounds. But at the end, what happens is that for each application, they have multiple service instances. Each service instance gives access to some external resource, like some database or so. And this is accomplished by some application security group. The application security group gives the access, but there is a known problem or known requirement that application security groups are not bound to applications. So in reality, what happens is that we have multiple applications and multiple application security groups not related to each other. Each application security group defines some rules. Those are the IPs and ports which should be enabled, like this. Some of them I have colored in the same color just to denote that they are the same, because this is how they define them. So what we end up is that we have a space with a lot of applications and a lot of security rules, which are, for each application, we have all the same security rules. This leads to various problems. I'll skip these first two because there is not enough time for now. But then, if there is time, I can tell. But the more interesting problem that we face, and that is really breaking us, is the IP table limits. The IP table, this is a firewall that sits on each virtual machine and manages the outbound traffic. So you can allow some ports and you can disallow some ports. And this is what actually all those rules means. They go into these IP tables, module and just create a big list of rules. In our landscape, it looks more like this. We have many rules that are quite similar. And until we were using static AHGs, we didn't actually know that this is a problem, because what static AHGs do is that they do the duplication of those rules. And at the end, for the IP tables, you get just a couple of rules. But with dynamic AHGs, this changed, because it doesn't do the duplication, and we get this huge number of rules. It took us quite a lot of time to understand what is the root cause. We did first some changes which helped only to some extent. Now that we know what is the root cause, we can actually compute that if we have some application with several AHGs, we have many applications per space, we have several rules per AHG, and we have a lot of LRPs containers running on each Diego cell. So like a napkin math, you get more than several millions of IP tables rules per cell. And in our observations, we see that it works until 500,000 IP table rules. Afterwards, IP tables becomes so slow that Garden cannot create containers. And this leads to, when we are doing the Diego cell updates, Garden cannot simply, it takes like 10 or 15 minutes just to create the container and initialize all those rules. And applications are unable to start on time. The instances fail. And in fact, the updates become non-zero downtime. So after the update, we have a lot of failed applications. And yeah, now that we found that the problem is with this duplication, currently we are doing some small fix in order to fix it, but this is an ongoing discussion that we're about to let with the community, how to fix this properly, where exactly the duplication has to be done. Then another interesting issue that we discovered just a few days ago, maybe a few weeks, and it started breaking our landscapes, is that the security groups, they're held in one table, which contains one ID field, which is of type integer, which means it can grow only to billions. But this field is incremented each time the application security groups are read from cloud controller, and it's incremented for each application security group. We have landscapes with several tens of thousands AHGs, and so a quick math shows that for those, these values incremented by about several tens of millions per day. So what happened is that at some point of time, the landscape started to just break. So first some, we disabled AHGs for them, then others, and at the end we realized that simply the updates of the AHGs were failing because they cannot increment this value anymore. The fix is currently mitigating this by just disabling dynamic AHGs, deleting the table, and then creating it again. But we're in the process of all discussing with the guys so to switch this to big int or something like this to get it better. Now let's see. I think we don't have much time for the others. The other two problems that I wanted to mention are that due to all those security groups in there, what happens is that each desired LRP becomes very big. So the desired LRP is a structure that holds the information about each container, and all those security groups just land inside. So what happens is that for each, it's encrypted. So when it becomes like 10 megabytes, it's very hard to decrypt it. And our Diego APIs just become overloaded, and we scale them up. At the end, there are no bigger virtual machines on the landscape that we can use. And this becomes something like a limiting factor of our landscapes. We have stopped onboarding of workloads on landscapes because the Diego API cannot scale anymore. And there is no fix for this, so we are just leaving it. And the other problem was a smaller one, but again important. When the root emitter wants to get which are the roots, which is something like several ports, it gets the desired LRPs and gets several megabytes. And we have many root emitters. All those root emitters request all LRPs. They do this each 30 seconds. They make a distributed denial of service attack to the BBS because it simply cannot handle this bandwidth, even if you are using the network optimized machines. And for this, this is a contribution that we made last few months, is that we added a new endpoint that the root emitter will just get the routing information that it gets, and this is how we optimize, and now can even use cheaper. So there are a lot of other issues that are interesting, but there is not enough time. Also from both of our teams, this is the thing that we are constantly fighting, improving due to needing to scale more. So this was it. let's see to the.
So if you have any questions, feel free, either now or find us later.
Yeah, we're here.
Yeah.
Vladimir, to you. So the IP table limit would. So just curious, the IP table limit can that be resolved by using IP sets instead?
Not so easy. IP set allows you to just have a lot of IPs and just match. So it's just for performance perspective.
Yeah.
But in our case, we just have a lot of IPs that have to be stored somewhere. And maybe also IP sets to some extent. But anyway, currently we found a way how to mitigate this by doing pool managed application. So say, just modifying the Porsche list to add some script. But this is something that we need to fix just to keep the same functionality for both static and dynamic users.
Okay, thank you.
And now, that is the problem.
Thank you. Do you have customers that are asking for IPv6 to avoid the NAT problem at all?
IPv6, I don't know, maybe.
It is something that is in the works, but it's going slowly.
Yeah.
So there's no hard push yet. There's a few customers that started asking for it a bit, but there's no, like, we need it tomorrow.
Okay, thank you.
Okay, thank you very much.